Okay, we're now going to look at, we're still looking at the sampling distribution of proportions, but now we're going to look at confidence intervals. So let's recall that the mean of all sampling proportions is the proportion, the population proportion, or P, and that the standard error, or standard deviation of P hat, the sampling proportion, is square root of PQ over N. And we can say that if we know that if NP and NQ are greater than or equal to 10, that we can approximate this using the normal distribution. So let's say that a recent survey found that 48 of 156, or approximately 30.8%, of Facebook users update their Facebook status daily. We want to find basically the mean and standard deviation, or standard error, and draw the sampling distribution of the proportion. So that's not too bad. So we basically know. We don't actually know the population proportion P. So we're going to basically estimate that using P hat. So we have, well, our sample is 156. We know that there are billions of Facebook users, right? But we're going to use 48 out of 156, where we're going to say that or estimate that our population proportion is 30.8%. And we're going to use that to calculate our standard deviation, or standard error, which is P square root of PQ over N. So we have 0.308 is our mean, and we have our standard error is 0.0, I believe our standard error is 0.037. All right, so we have normally distributed, we have normal model with our mean of 0.308, our standard deviation of 0.037, and that's because we know that NP is greater than or equal to 10 and NQ is greater than or equal to 10. So there's one standard deviation away from the mean, and we can do two standard deviations away from the mean, and that's approximately our normal curve. If we know our true population proportion, the empirical model says that 95% of all sample proportions, P hat, will lie within two standard deviations of P. So I can take random, these little sample P hats in red. In other words, I can take a proportion of 100 people, a proportion of 100 people, I could survey 100 people, whatever those P hats are, 95% of them lie within two standard deviations of the population proportion. This little part in gray here, P hat 6, it's possible, of course, that I get something that's out there. In other words, it's possible I just get a sample of people that update their user status like all the time, and they're big Facebook users. It's possible that I get a proportion or a sample where there's a very low proportion of daily Facebook users. So, you know, most of my P hats, 95% of them, lie within two standard deviations of the population proportion. Well, another way to say that then is if I randomly select a sample proportion, that there's a 95% probability that that sample proportion will lie within two standard deviations of the population proportion. In other words, if I randomly select one of my P hats, all right, so let's say that I select, I don't know, we'll select, how about P hat 3, and I am going to make a red line that's supposed to be two standard deviations away from P hat 3. I'll go in both directions, and notice that within that red line, the population proportion is actually there, so it lies within two standard deviations. If I take P hat 2 and go within two standard deviations, then the population proportion still lies there. But if I take P hat 6 and go two standard deviations away, I will not get the population proportion there. So P hat 6 does not contain P, the population proportion. All right, so coming to confidence intervals. If I want to find a 95% confidence interval for the proportion of Facebook users who update their user status daily, let's say, again, I do not know the actual population proportion. If I knew the population proportion, I wouldn't need to do a confidence interval. So I take a random sample of 156 users. 30.8% of those users actually update their status daily. And we say, okay, well, 2 standard deviations away from 30.8% is 38.2%, and 2 standard deviations away from 30.8% is, in the other direction, is 23.4%. In other words, we're 95% confident that between 23.4% and 38.2% of all Facebook users update their status daily. Another way to write the confidence interval is 0.2324, comma, 0.38382. So this is a 1 proportion Z interval, and where the mean, or the P, is 0.308. The standard error is 0.037. And actually, if we could rewrite this as our sample proportion plus or minus Z times the standard deviation. So we know that the sample proportion is 30.8%. We know that the standard error is 0.037, but we don't know our Z critical value or cutoff values. And these are basically cutoff values for the middle, and if it's a 95% confidence interval, for the middle 95%. So, using the empirical rule, we just said, hey, the cutoff values were plus or minus 2. This was basically an estimation. So if it says use a table or technology, we have a couple of ways to do this. And if we know that the middle is 95%, we know that in the 2 tails, it's 5% over 2, and that's because this is symmetric, and it's 100% under 100%, or 1 is the area under the normal curve. So the area to the left is, for negative Z star, is 0.025, and the area to the left of Z star is 95% plus, or sorry, 0.95 plus 0.025, or 0.975%. On a TI-84 calculator, you could do inverse norm of 0.975 and get the critical value or cutoff value. On a TI-84, you would use inverse norm of 0.025. However, in a Z-chart, we're going to basically look for area of 0.025 and then go out to find the Z value. So I find right here, we have 0.025, that's the area left, and as I go out to find that Z value, I get Z is equal to negative 1.96. Now, because the normal curve is symmetric, when I have Z equals negative 0.196 with 0.025 to the left, and I know that I have 0.025 to the right, this is positive 1.96. We recall basically our formula, we just needed our Z cutoff value. So more appropriately, instead of plus 2 and minus 2, we used 1.96. By the way, this Z times the standard error is called the margin of error. Basically, we're saying this is a 30.8% plus or minus some margin of error. In this case, 7.25%. I want you to notice that basically 0.308 lies in the middle of our confidence interval, and it's plus or minus some margin of error. And we can, so given a confidence interval, we can also find the margin of error. If you would like to do a 1 proportion Z interval all in a couple of buttons on the TI-84, you're going to choose, let's see, you're going to choose stat. And once you choose stat, you're going to choose 1PropZInt. Actually, so I believe that's you will choose the menu test, and then 1PropZInt. You have x equals, n equals, and then the confidence level. X equals, in our case, I believe it was 48 and 156. That was our 30.8%. And then the confidence level was 95% or 0.95. If you want to calculate a confidence interval in staccato, you will go to Statistics, Confidence Interval, 1 Population Proportion, and if we do 48 over 156, confidence level 0.95, that gives us our sample proportion 30.8%, our margin of error, and our confidence interval right here.